There we go. All right. So let's move this thing over here. All right. Um, Worldwide, 20 births and 8 deaths per 1,000 people in 2009. What was the global population growth rate? Before we even start this, let me move this down here. Go down here. All right. Um, well, we're going to need a formula. So population growth rate is the crude birth rate minus crude death rate. And then we divide it by 10. I'm going to explain why right now. Crude birth rate and crude death rate are the number of births and the number of deaths per 1,000 people per year. And it's nice because in this chapter we are indeed talking about people. They're always expressed in terms of per 1,000 people. But then growth rates, they always want you to calculate in percents. So if these rates are per 1,000, what's a percent? Means per 100. So how do you go from per 1,000 to per 100? Divide by 10, and that's why the 10's on the bottom of this. That makes sense? And that's just, I don't know, it's just the way it is. So, to do this, let's put another color just for fun. Give me a bell. So this equals the crude birth rate here. Luckily, they gave us per 1,000 people already. So the birth rate is 20 per 1,000, so 20. Minus 8, because we have 8 dying, divided by 10 to get to our percent. So that's going to be 12 over 10, or 1.2% growth rate. Make sense? And that's really all there is to it. All right. So our last example was global, and we don't have a lot of humans entering or leaving the Earth, aside from by being born or dying. It's really the only way out. So, or in. We're going to look at this one for a metropolitan region. So, I don't know, the Charlotte metro area. So a metropolitan region of 100,000 people has 2,000 births. Uh-oh. We're no longer talking per 1,000, we're talking per 100,000. So we're going to have to mess with that right off the bat. Also, though, we have people moving in, and we have people moving out. So we've got to take all of that into consideration. So let's first move this thing down. And let me write this out as a formula. It's the same as our last one. Our growth rate is going to be, I should have done this out at the top maybe, but our crude birth rate minus our crude death rate, but we also have people coming in and people going out. So it'll be our crude birth rate plus immigration minus the crude death rate plus emigration. What's emigration? Yeah, people moving out. And again, since both of those things, or all these things rather, are going to be expressed per 1,000, we're going to divide it by 10. But first I want to back up to here. For our crude birth rate equals, we have 2,000 per 100,000. But we've got to, but we've got to express that in terms of per 1,000. So how do we do that? Oh yeah, all right, I like that. That's a good reply too. How would we just knock off a couple of zeros? So to go to 1,000, we knock off 2 zeros, or divide by 100, whichever you're more comfortable with. So equals 20 per 1,000, or 20, since we express this in terms of 1,000. Crude death rate equals, let's see, we had 500 deaths. So 500 deaths per 100,000 people in that metro area. Oh, no, you're okay. So let's knock off a couple zeros to get to 1,000. Knock off those. Knock off those. Is that right? Yep. Equals 5 per 1,000. So, and then we've got the whole immigration and emigration situation to look at too. Let's do that. So all we're doing is trying to convert this to per 1,000 because those are the units that we talk in. So, yeah, let's do that. 200 immigrants. So let's do M and M. And this would be 200 per 100,000, which is going to be what? 2 per 1,000. So our immigration is 2. And our emigration is, where is it? 200. 200, whoops, did I just do that wrong? Aha. So immigration is 100. So 100 per 100,000 or 1. And this one is going to be 200 per 100,000 or, oops, 2. Does that make sense? Essentially, yeah. I know, that's kind of the tough one. So, so let's do this out. Growth rate is going to be crude birth rate, which is, let me do this in another color, I thought. Crude birth rate is 20, so equals 20 plus, what's our immigration? 1. Minus crude death rate, 5 plus 2 over 10. And that's going to be equal to 21 minus 7 over 10 equals 14 over 10 equals 1.4%. So if you can basically remember, I mean, it's going to be, just remember that the rates are always expressed per 1,000. Get to that first. It's just basically birth rate and immigration minus death rate and emigration over 10 gets us to 1%. And I'll give you a few more practice problems. But what time is it? It's time for the rule of 70. Ooh, it's the best rule ever. No, it's a good rule. All right, you'll like this rule. I swear to you, you will. It's a good one. All right, we'll use this color, whatever it might be. You're going to like this math. Guaranteed. At a growth rate of 2%, how long will it take a population of 50,000 people to reach 100,000? Yes. So, 50,000 to 100,000, which I'm missing a 0 right off the bat. So let's fix this problem. There we go. What happened to the population if you went from 50,000 to 100,000? It doubled. I'm so happy to hear that, because I have a great rule for doubling time. It is known as the rule of 70, and you need to know this. Someone much smarter than I figured this out. What would you need? Anyway. So the idea with this is doubling time in years is equal to 70 divided by the growth rate. So in this case, it's going to be, I'll go back to red, equal to 70, because that's our magic number. Oh, I thought I went to red, but I guess I didn't. 70 divided by, what's the growth rate? 2. No, don't put it in decimal form. That's a good question. Leave it as a percent. Here, let's even write this out. As percent, not decimal. And some people do convert that, so that's a good point. Good question. All right. So 70 divided by 2 is, my goodness, I let this one come out even. So that means what? 35 years, what happens in 35 years? The population doubles. It's an awesome rule. So 70 divided by the growth rate as a percent is how many years it'll take for that population to double. You can't beat that rule. It's like the 10% rule. All right, here we go. So, and to remember that we can move this equation around so that if you had to calculate the growth rate and you were given the years, you could do that. So if we had that triangle thingy or steering wheel, you remember this from physical science? Did this, I think?
Yeah, I did this.
Yeah. So like 70 goes on the top, right?
Yeah.
And then percent on, doesn't matter, does it?
Kind.
Well,
No.
I'd get confused if it wasn't on the left.
You want on the left?
I wouldn't like it.
All right, percent.
I'll just see you later.
What are we gonna put here?
Years.
Years. Years. So then if you just cover up, you can do the percent as 70 divided by the years, or you can do
Percent time years.
percent time the years,
Well,
but you wouldn't ever really do that. So yeah, I think we pretty much got this. So essentially, what if I gave you this the other way around? What if I said population doubled in 35 years, what's the percent growth rate? How would you calculate that?
70 divided by
70 divided by 35. So, oh really? Just a triangle? So growth rate in this case would then equal 70 divided by years. So you could do that, or commonly you do that. And that's good enough.